Hello, Machine Shop Math fans. We're back again. This will be video 10, part 2. We'll be dealing with what you'll be having to deal with Exam 3. We're going to enter into trigonometry. Now, I'll draw your attention to the master formula sheet, Appendix E part. It should be page 16 of the 22 pages. We see trigonometry here. We see the Holy Trinity: sine, cosine, tangent, cotangent, secant, cosecant. We also see the law of sines, and we see the law of cosines. Now, we will be dealing mostly with just the Holy Trinity of trig. Actually, we'll be dealing only with the Holy Trinity of trig: sine, cosine, and tangent. Dealing with the right triangle. Now, if you have a triangle that's not a right triangle, and you have the angles and sides, you can use the law of sines to work the triangle. So if you ever have a problem like that, you need to look, if it's not a right triangle, you can look at the law of sines, or you can look at the law of the cosines, given two sides and the included angle. You can also work on that triangle, okay? But we'll be dealing with the right triangle. So let's go down here to Trigonometry Expanded. And you will see that it's the same chart, but I have algebraically rearranged the sines, the cosines, and the tangents for you. So if you're using sine and you need to find the opposite side or the hypotenuse, then this is what you'll have to do. This is how it looks, and this will become more clear as we work through this. So, sine, cosine, and tangent deal with the right triangle only. Now, let's go over to our notes. And like I said, these notes were done for the spring short semester. So again, pay attention to what I tell you. This is not video 6. This is 10, part 2. Okay? All right. So pay attention to the title of the video and you'll be okay. Now, what I refer to as the Holy Trinity of trig is sine, cosine, and tangent. Sine, cosine, and tangent. Now, you can either follow along by printing out your Holy Trinity of trig, the Trigonometry Expanded, and you'll see sine, cosine, and tangent. Now, sine of any angle is the opposite of that angle over the hypotenuse. The cosine of any angle is the adjacent side over the hypotenuse. And the tangent of any angle is the opposite side over the adjacent side. Now, cotangent and secant and cosecant is just 1 over. It's just the inverse of this. It's 1 over sine, 1 over cosine, 1 over tangent. So this would be this is actually 1. This is actually 1. Draw it. Okay. To do this for each one of these bloody things. Oh, cotangent is the adjacent over the opposite. So that's 1 over the tangent inverted. And this is 1 over the cosine. And this is 1 over the sine. So if you have a formula that needs a cotangent, a secant, or a cosecant, just use the 1 over tangent, the inverse of 1 over cosine, and the inverse of 1 over sine. Because you don't have a secant, cosecant, and cotangent button on your calculator. You do have a tangent, cosine, and the sine, and you have the reverse switch for these, which we will discuss here in a moment. Okay? All right. So let's go over to our notes. Now, exam 3 has got a lot of moving parts. It's very extended. You need to give yourself enough time to study for it and prepare. So, trigonometry expanded, the holy trinity of trig, sine, cosine, and tangent. Now, the reverse of sine is sine raised to the negative 1. And the reverse switch for cosine is cosine raised to the negative 1. And the reverse switch for tangent is tangent raised to the negative 1. Now you're probably thinking, what in the world am I talking about? Well, this is referred to as the arc sine. This is referred to as the arc cosine. This is referred to as the arc tangent. Okay? It's not the inverse. The inverse of tangent is cotangent. All right? It's the arc sine. And you'll have that on your calculator. Let's get the calculator up. There's our calculator. So let's go to trigonometry. You'll see that we have the sine button. Well, I lied to you. We have a secant, a cosecant, and a cotangent button on this one. Isn't that special? Wow. Cool. You see, you just can't trust adults. That's why Peter Pan didn't want to grow up. Well, anyway, so we have the sine, cosine, and tangent. Okay? All right. Now, if we hit the second function key, we see sine raised to the negative 1, and cosine raised to the negative 1, and tangent raised to the negative 1. Now, this Windows calculator is a bit cumbersome, but we will go through, and I will show you how to manipulate this. There's going to be several videos. There'll be video 10, part 1, 2, maybe 3 and 4. Like I said, exam 3 is pretty extensive. Exam 4 is nothing but an extensive homework assignment. A lot of repetitive work. So let's move on. Let's move on. Let's go back to our notes. All right. So in dealing with our triangle, we need to come up with some terminologies. All right. This is angle A. This is angle B. And this is angle C. Normally we don't label C because it's the right angle, but side C is the hypotenuse. We already know that. We've already crossed that bridge, plowed that ground. Side A is the side opposite angle A, and side B is the opposite of angle B. Side B is the opposite of angle B. Side A is the opposite of angle A. So, side A is the opposite of angle A. Side A is adjacent to B, angle B. See, it's adjacent. If you're standing here at B and you're looking into the triangle, you can reach down and touch A. The hypotenuse is that long thing that runs off over there. Side B is the opposite of angle B. Side B is opposite angle B. And side C is the hypotenuse. And yes, it's opposite the right angle. All right. Now, I generally don't like using A, B's, and C's to teach this because it's conventional, but you may not have your angle listed as A. It doesn't matter whether it's A, B, Z, or Billy Bob, or Mary Sue. If I'm standing here at this angle, and it's a right triangle, and I'm looking into the triangle, the side I can reach down and touch that runs straight away from me to the right angle is the adjacent side, no matter what it's called. But here it's called B. The side running between the angle that I'm standing in, looking in, and the angle that's the side that's opposite the 90 is the hypotenuse. So, to be more precise, the side of any angle is the opposite over the hypotenuse. The opposite side over the hypotenuse. The cosine of any angle is the adjacent over the hypotenuse. And the tangent of any angle is the opposite side over the adjacent side. Now, you're going to be using tangent a lot, and you'll use sine a lot, and cosine, believe it or not. All right, so let's start with sine. Let's go ahead and start with sine. Okay. I'm going to have to activate this. There we go. So let's start with the sine function. We're going to toggle back and forth to the calculator. So, we know that the sine of any angle, is the opposite over the hypotenuse. Now, from our trig expanded, see, we have the sine is the opposite of the hypotenuse. If we're having to deal with sine still, and we need to find the opposite side, then the sine of the angle times the hypotenuse gives us the opposite side. If we're having to deal with sine, then the hypotenuse equals the opposite side over the sine of the angle. Okay? Now, how do we know to use sine, cosine, or tangent? Well, hopefully that will become evident to you. Okay? If you're dealing with a problem and you have an angle, so in this case we have an angle, yes? Angle, and it happens to be labeled A. This angle here, we have an angle, right? We have an angle. And we have an opposite side and we have a hypotenuse. And we don't care about the adjacent side, or we don't even know the adjacent side. We don't care. Maybe we're only trying to find the opposite side. So if we're dealing with angle, opposite, and hypotenuse, it's got to be some form of sine. It'll either be this form of sine, it'll be this iteration of sine, or it'll be this iteration of sine. You see, we have opposite, hypotenuse, and angle. Opposite, hypotenuse, and angle. Opposite, hypotenuse, and angle. So that's the first question you need to ask yourself in the conversation or in the problem that you're trying to solve. What am I dealing with? I'm dealing with an angle. I either know it or I'm supposed to solve for it. I've got a hypotenuse of my triangle, and I have my opposite side. So it's going to be one of these sine iterations. All right? So we have angle A, we have a hypotenuse, we have an opposite in this conversation. Therefore, we must use some form of sine, right? Or SINE. Look at trig expanded formula sheet. So you should keep that open. We do not know the opposite side. So let's solve for the opposite side. So the opposite equals the sine of the angle times the hypotenuse. Now, we're going to say that our angle, start assuming we're given an angle of 60 degrees, and the hypotenuse is 14 inches, okay? 14 inches, and our angle is 60 degrees, all right? And we don't know the opposite side. We don't know the opposite side. We're going to solve for it. So we've got an angle, we got a hypotenuse, and we got an opposite side. But we don't know the opposite side. So we're going to look at the formula using sine, because it's opposite, angle, and hypotenuse. And we pick this one. We pick this one right here. So, opposite equals sine times the hypotenuse. So that's the sine of 60 degrees times 14 inches. So the opposite should give us 12.12435565. And let's see if that works out. So we got 60 and 14. Let's go to the calculator. We're going to the calculator. Now we're going to trigonometry. We get 60. That's why I hate this calculator. 60 sine, right? How about 60? Trigonometry. Sine of 60 times 14. It's a whole lot easier using that Casio. And we get 12.12435565298214105105 blah, 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 blah. That's more decimal places than we deserve to own. So let's just say 12.12435, we'll say 12.1244, if we were going to actually do something with this. So is that what we got over here? Well, looky there. 12.124355565. All right. So, did you follow that? Let's go back and do it one more time. So let's clear everything out. We're going to say 60. We're going to pull up our trig function, hit sign, and multiply that times 14, because that's what we're doing. And we get 12.12435565. Now, what if we didn't know what the angle was? What if we only knew that this was the side of the opposite side? So let's divide this by 14. Okay, that gives us a decimal, right? Well, I want to know what the angle is, because that's not the angle. So let's go to trigonometry. Let's go to the second, and let's use the reverse switch for sine, which is sine raised to the -1. Wow, look, we get the 60-degree angle, so we just solved for our angle. So let's go back and do that problem. Trig's a very powerful tool. Okay. Okay. Here's the next one. Let's assume that we know angle A is 60 and the opposite is 12.12435565. And we want to solve for the hypotenuse, right? Okay. So let's look at the formula sheet. The hypotenuse. If we want to solve for the hypotenuse, we now know the opposite side. We know the angle. So we got to use this thing right there. So you take 12.124355565, you divide that by the sine of 60, and you should get 14. So let's see if that works out. 12.4355. 12.4355 divided by 60, trigonometry function sine equals, and we get 13.99999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999. That's pretty darn close to 14. Now, if I'd have put all those decimals in, if I'd have put every one of these in here, every one of these, if I'd have taken every one of these, right, this whole string of decimals, 12.124355652982141054692, and divided that by the sine of 60, we would get 14. It would finally kick this over to 14. There we go. So let's do that. Let's say divide 60 sine equals 14. So that's a good example of the degree of precision. So this, I used a rounded number, and I didn't quite get 14. I came back, got our original number, and we got 14. So that's a good example of how the degree of precision is affected in your calculations. All right. Now let's move on. So we figured out that the hypotenuse is really 14. Okay. Let's go down here. Now the third thing, let's assume we know that the opposite side is 12.124355565. And let's assume that the hypotenuse is 14, but we don't know the angle. don't know the angle. So we have to use this one up here. So we have to use this formula, sine of the angle equals opposite over the hypotenuse. Now, in this case, we're going to get a ratio because this is a number and that's a number, yes? Right? So we're going to get this number divided by 14, and we're going to end up with that ratio right there, but that's not our angle, is it? No, it's not. So we got to use the arcsine function, sine raised to the -1. So let's go do that. Let's go back to the calculator and see if we can pick up that long number. Here it is right here. All right, that number right there, okay? How did I get that before? And we're going to paste that number up there in our register. Now, that's one good thing I do like about this calculator. So after all my complaining, divided by 14, remember that's what we're doing. Okay, we don't know our angle yet, so that's our ratio. So we're going to come over here. We know we're having to use sine because we're dealing with the opposite angle and hypotenuse, yes? We're dealing with opposite angle and hypotenuse. You go to trigonometry. We don't want sine, cosine, or tangent. We want the arc sine. So we're going to hit second, hit the arc sine, and bingo, we get 59.999999999999999. So that's close to 60 degrees. Very, very close. I would say that's close enough for government work. All right, so that's what we did down here. So we use the arcsine function, sine to the -1, to get that angle. So sine -1 of this ratio, 0.866025403, gives us 59.999998 degrees. Well, I would say that's pretty close to 60 degrees. And this is from the Casio FX260. Your calculator may round it to 60, but even the Windows calculator with all those decimals still yields 59.999, way out there, right? We're going to say 60 is good enough, okay? Now cosine, guess what? Cosine's the same thing, right? Except cosine deals with the adjacent side, the angle, and the hypotenuse. Adjacent, hypotenuse, and angle. So if your conversation deals with the angle, the adjacent side, maybe you know the adjacent side and you're trying to solve something else, or you're trying to solve for the adjacent side and the hypotenuse. If your conversation has angle, adjacent side to that angle, and the hypotenuse, you're going to use some form of cosine. You don't have a choice. Well, you do have a choice, but your answer will be wrong. And I won't have a choice but to count your answer wrong. So angle, adjacent, and hypotenuse has to be some form of cosine. So the cosine of the angle equals the adjacent over the hypotenuse. The adjacent, using cosine, is cosine of the angle times the hypotenuse. And the hypotenuse in cosine land is the adjacent divided by the cosine. All right? Now let's assume, again, that we have a 60-degree angle. There's a reason I'm keeping the angle and the hypotenuse the same. You'll see this in a minute. Okay. And the hypotenuse is 14. All right? So we want to solve for the adjacent side B. So it's got to be some form of cosine, right? So we go up here and we look at, you either go over to the formula sheet and you look at what I iterated for you, or I replaced it here so we don't have to bounce back and forth. So our adjacent side equals cosine of the angle times the hypotenuse. The cosine of the angle times the hypotenuse. Cosine of the angle times the hypotenuse equals the adjacent. So that's the cosine of 60 times 14. We get an adjacent of 7. Okay? This becomes 7. And we already know what this thing is. This is 14, hypotenuse. And we know what this is. It's that freaking 12 point whatever, blah, 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 blah. It's way that thing way up there. Right? Okay. So let's go use the calculator. Play with it some more. You need to learn to use your calculator. You need to play with your calculator. So what did we say? What did we say? Oh my God. My old timer is kicking in. 60 times, cosine of 60 times 14, yes? Okay. All right, cosine of 60. Let's clear this out. 60 cosine times 14. You already know this is going to be 7 because that's 0.5. All right, so that's 7. 60 trig cosine 0.5 times 14 equals 7. Okay. So let's go finish this off. All right, so that's 7. Now let's assume that we have an angle of 60 and the adjacent side of 7. What does our hypotenuse get calculated out to be? So we go pick this formula up here. The hypotenuse is the adjacent over the cosine of the angle. All right, so let's plug in 7, divide that by the cosine of 60 and see what we get. Okay, that's up there. Divide 60 trig cosine is 14. We started off with 7. We're going to divide that by the cosine of 60. Cosine of 60 is 0.5. So it's 14, right? Okay. So far, so good. All right. Now, assume we know that the adjacent side is 7, the hypotenuse is 14, but we don't know the angle. And again, in this case, we will have a ratio on the right side of the equal sign, right? We said that the cosine of any angle is the adjacent over the hypotenuse. So if we put a number over here and a number here, we get a ratio. We already know that it's a percentage, a point, whatever. Okay, so this is going to be 7 over 14. So 7 over 14 is 0.5, and that's not our angle. That just says some cosine, the cosine of some angle equals that. So we've got to use the reverse switch. And what's the reverse switch for cosine? Is cosine raised to the -1. So if we go cosine, the arc cosine of 0.5, then we get 60 degrees. And let's go make sure that the world is right. So we know that 7 divided by 14 is 0.5, yes? So let's go find the arc cosine. Let's find the reverse switch for cosine. There we go. Whoop, look what we got, 60. Now this ran us to 60. It didn't run us to 59.999999, right? This over here. It didn't run us to that. It ran us straight to 60. So, interesting algorithms in the calculations algorithms, all right? All right, so let's go back to our study sheet. Good thing about the video, you can play it back, okay? So this one, tangent's the same way. The master formula sheet for tangent is over here. tangent of the angle is the opposite over the adjacent, opposite tangent times the adjacent, and the adjacent's opposite over the tan of the angle. And I've written them down over here so we didn't have to flip back and forth. All right, so here's tangent. The tangent of any angle is the opposite over the adjacent. That's the reason I don't like the A and B thing. It's just wherever I'm standing in the triangular universe, I know what my opposite side is. I know what my adjacent side is. So it never made sense to me, even when Sister O'Brien was trying to beat trigonometry into my evil, sinful head. All right. All right, so, and the opposite is the tangent of the angle times the adjacent. And the adjacent is the opposite divided by the tangent of the angle. So again, let's assume that our angle is 60. And we're going to go back to the adjacent side of 12.1235565. And we want to solve for the adjacent side. Okay? So we'll pick the adjacent. It's opposite over the tangent, right? So the adjacent's opposite over the tangent of the angle. So that's going to be 12.124355565 divided by the tangent of 60 degrees, and the calculator gave me 6.9999998, which is close to 7. Let's go see what this calculator does. Okay. We've lost our... No, there it is down there. Good job. It's got a running stack for us. Okay, that's the long number. So we're going to copy that. I'll put this up here. Paste the number in the register. And we're going to divide that by the tangent of 60, yes? Divide 60. Tangent. And we get 6.999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999. Way, you got 9s way out here, okay? So, that's 7. All right. So, let's see. Now, second, this was the first thing we did. All right, we found the adjacent. Now let's solve for the opposite side using the tangent, okay, of the angle. So the opposite is the tangent of 60 times the adjacent, okay? So 60 times 6.99999. So let's go back to the calculator. Times 60 tangent equals 12.12435565298214105 blah 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 blah. So now we're getting close back to where we started from down here. Okay. Now I'm being a little silly, dragging all these decimals out. Well, the point I want to make to you is, what is the degree of precision that you need to have? Well, it all depends on what you're doing. It all depends on what you're doing and how precise you need to be. If you can't measure past 5 decimal places, if you can't, then why calculate this? If this is your final answer, then whack it off at what you can measure, right? So in this case, 1, 2, 3, 4 decimal places, 5. So we might go 1, 2, 4, 4. So it might be 12 and 124 thousandths and 4 ten thousandths of an inch. It depends. Your mileage may vary. Okay. All right, so we solved for the opposite side. Now let's solve for the angle. So first we're going to use what we calculated, 6.999, this thing here. Now if we do that, we're going to get 60 degrees. If we use 7, we're going to get 59.999 degrees in our calculator. It's a computational error. That doesn't mean it's wrong. Everything's got an error, and it's a tolerance due to the decimals and the algorithm and how the calculators calculate the number. It's okay. Your world's not going to end here because of this, all right? So if we took this number and divided it by 6.9999998, now I'm starting to get confused. Divide that by 6.999999999 oh my God. Upside down 9. 9999999999999. Hey, I think that's enough. Don't you think it's enough? I think it's bloody enough. Go over here, and we're going to use the reverse switch, the arctan, and we get 60 degrees. I put too many decimals in there. That's why it's 60 and a bunch of crap over here. Okay. So what if we came and we used this number here? I'll do that. Copy. Paste. And we divide by 7. Because that's the official side, right? I mean, that's what we are saying, the sides. So, and then we come over here and we take the arctan. We end up getting 59.999 degrees instead of 60. So, don't get too freaked out. This is 60 degrees for all intents and purposes. All right. Now maybe if you were doing some kind of line of sight to Pluto, but you don't travel in space line of sight. So as far as we're dealing with Newtonian physics on this planet, it's good enough. All right. I think that pretty much covers the manipulation of the basic functions of sine, cosine, and tangent. Play this video back over and over and over again, and you will get proficient at this. All right. Now the next thing, this video is 38 minutes so far. I guess we could check Pythagoras. We've got a few more minutes, and then we'll pick up where we left off. We'll pick up in the next video at the sine bar. Okay, so let's check Pythagoras. Let's check Pythagoras. I'm going to make a note on my master sheet here. Yeah, we'll make a note. Master sheet that we'll pick up with the sine bar. This will be video 10 part 3 sine bar. All right, so let's go back and do Pythagoras with trig. Okay, now we knew that our triangle is 14. We know for all intents and purposes the opposite side of this angle A is 12.1243555, and we know this side B, the adjacent side to A, or the opposite side to angle B, is 7, or 6.9999998, right? Okay. So, so let's check and see what happens. Now we said Pythagoras, c squared equals a squared plus b squared, right? So if we take 14 squared, so that means that 12.124355565 squared plus 7 squared should equal 14 squared, right? And then 14 squared, if we do it the other way by using 6.999999998 squared, is supposed to equal that, right? So let's figure out. So 14 squared is 196, right? 14 squared is 196. 14 squared is 196. Okay. 14 squared is 196. All right. So you're just going to have to trust me on these numbers. You can check me with your own calculator. So if we square 12.124355565, we get 146.999. It's the same number, 146.99999. Now the only variance here is between 7 squared and 6.9999998 squared. So that's 49, which is 7 squared, or it's 48.999999997 if we square this, okay? So if you add these together, we end up both of them equaling 195.99999 and 195.99999, okay? So the order of magnitude or degree of precision, does it matter? It depends, okay? Like I said, it all depends. All right. That's pretty close to 196 computation-wise. Okay. So, so I wouldn't worry too much about it if I were you. All right, that's going to end this video. We're at 42 minutes. We'll pick up on video part 3 of video 10. And use some practical uses for the sine and cosine. All right, next time.